Hello, welcome to another stream. How about that? Welcome. How are you all doing today? So today is Sunday, if I'm not mistaken. And today, according to the schedule, we're doing what? We're supposed to be doing game development, but today I decided before we start game development, I just wanted to program a little bit in Adb, and I was actually learning Adb off screen quite a lot. And I wanted to try to implement something simple in it, just to showcase what the language is capable of and its different features and stuff like that. And usually, such a project, for a good candidate for such a project to, just try out the language is Game of Life. And I already implemented such a Game of Life in C++ some time ago. It's actually a very simple implementation. So let me go somewhere here. So it's located, it's basically example in AIDS. For those who doesn't know, AIDS is a replacement for STD. It's a replacement for STD, and one of the examples there is a simple Game of Life thingy, which looks like this. So it renders in console without using any incurses or anything like that. Yeah, why not just go ahead and implement something like that in Ada, just to try different interesting features of the programming language. So that's what I was thinking to do before the stream. All right, so hello everyone, by the way. Hello iStream Chess, Katie-san, Yatanasov, Belgianul, Script SH, NVP 135, Noah before the bet. Hello, Panapodio, welcome. AIDS for Ada when? Well, we're starting with implementing example from AIDS, so maybe later we're gonna implement the whole AIDS for Ada. So yeah, so that's probably how it's gonna go. All right, so let me see. Let's just go ahead and do that. How about that? Ada goal. So it's gonna be Ada goal, and don't give a haha. Very funny. So let me pour a cup of tea. By the way, my kettle just broke. It gave me the last cup of tea and broke. So I guess F for the kettle. Subscribe so you can buy a new kettle. No, not really. Like you don't have to actually have spare money for a new kettle. Don't worry about that. As a matter of fact, I have a spare kettle. Like it's an old one, but I can use it to make a couple of cups of tea, so it's not that big of a deal. Just fix the current one. Yeah, it's probably something simple. Maybe, I don't know. I'm too lazy for this kind of stuff. Yeah. Alright, so this is the last cup of tea from the kettle. Maybe, we'll see if I manage to maybe fix it. Alright. So let's start with a file, goal ADB. So ADB file stands for Ada body, right? Because there's Ada specification and there's Ada body. So essentially they're similar to, C/C++ header files and C files, but they're not like files that are intended to be included using preprocessor. So they're just two different files for describing a package or a module. Right, so semantically they're nothing like in C/C++, they're like proper modules. As a matter of fact, I think module system in Ada is closest to a camel one. Yes, a camel and Ada have a very similar package system. Or module system, whatever you want to call it, of course. Use samovar, yeah. I do have like an actual samovar, which uses, coals and stuff like that, but I think it's kind of dangerous to use it inside, so I'm probably not going to use samovar. Sorry. Maybe I should bring samovar to the stream one day, but it's so fucking huge and heavy, so I don't think I want to do it, at least right now. So yeah. Cheers, by the way. use electric samovar. Well, I don't have electric samovar, so I'm talking about the samovar that I have here right now in the apartment, right? So I don't have an electric samovar, I have the regular one. Alright, so let's define the procedure. Ada looks more like Pascal, so that's why it has keywords like procedure, function, and so on and so forth. So we're gonna call it a goal. Maybe I can call it game of life, because why not? Yeah. So here's the begin and here's the end. So then, to indicate that your translation unit depends on other translation unit, you use with clause. Ada text.io. The only thing we need to have here is Ada text.io. So and then you can do something like Ada text.io put line, right? And you can say something like hello world. Isn't that amazing? I think it's goddamn fucking amazing, right? So now we can try to compile that. I'm gonna use not make. I could have just used a GPR build. With GPR build, you can also just provide the Ada file. But the problem with GPR build is it generates shit ton of garbage. Holy shit. I wish I could quickly actually remove it. So let me try to remove thing like this. So I want to remove everything from here. Right, then I want to remove everything that is std here, like this. And then I want to remove everything like Ali, Beck, CH, I don't know what these things are. I only care about the executable. So if you use something like not make, you're gonna end up with actually a little bit cleaner situation. You're only gonna have like things that are needed. The GPR build probably generates some intermediate shit that you don't need for such a simple program. I don't really know how they work, but yeah, we're gonna use gnat-make. With gnat-make, you can also enable additional warnings, gnat-wa, which basically equivalent of all warnings, all from GCC or something like that, right? So yeah, it basically will provide more warnings. Alright, so to not add this prefix every time I want to use put line, I'm gonna just use Ada text.io. This is like similar to using in C++, right? So essentially you have a package and then you do use, and it basically puts everything from that package into the current scope, and it makes it a little bit easier to work with. Yeah, and here's another interesting thing. So here's the warning: the file name does not match the unit name. So I have a file name called goal, and the unit name is game of life. So it's not that big of a problem, but it's something worth generating a warning about. Ada is a very bureaucratic language, what can I say? So let's actually rename it back to goal then. Sure. Sure. Might as well actually construct something like this. So yeah, here's the hello world. Alright, who knows what is a game of life? So hello Squat Monkey, welcome to the stream. Hello Renak. Who knows what is a game of life? So we implemented it so many times in the stream, I assume everybody knows. You know, cells going crazy. Yeah, that's a good description of game of life. It's a game where you win by dying. Well, also by being born as well, I guess. Maybe, I don't know. It depends on the criteria. I'm going so emotional with me. Yes, it's a very emotional music, not gonna lie. It's so cool with gliders and shit. Yes, it is in fact cool. Cellular automata go. Okay, so game of life. Let me take a look. Will it have GUI or console only? Only console, because it's a very quick project to showcase Ada. Right? Just a very quick project to showcase Ada. All right. So here are the rules. Essentially, you have a grid, right? You have a grid, and you have cells that can be in two states. It could be alive, it could be dead. Make sense? Hello, plots. Hello. So, and here are the rules. Any live cell with 2 or 3 live neighbors survives. Any dead cell with 3 live neighbors becomes a live cell. What is this English? Okay. All other live cells die in the next generation. Similarly, all other dead cells stay dead. So, yeah. This is basically the rules. I guess it's a simplified rules. And these rules which compare the behavior of them can be considered. Okay. This is more strict rules, but I didn't want to read them because they're too boring. Anyway, so we're gonna implement something like that, right? We're gonna implement something like that. So since we have cells, right, in Ada, in the spirit of Ada, right, we need to introduce type for the cell, right? So it's gonna be type cell is dead or alive. This is enumeration or some sort of a discrete type. Which is quite interesting, not gonna lie, quite interesting. So, and if you try to build that, it seems to be working, so yeah, you can think of it as enumeration. Alright, so the next thing is to define a board. We could have actually defined something like this, board, which is array, where you have like from 0 to height, then from 0 to width, and then of cells, and call it our board essentially, right? Call it our board. And on top of that, by the way, if we wanna you know, enumerate actually from 0 to n-1, we have to do -1, because the ranges in Ada, they are inclusive, they include both of the ends, right? And on top of that, we're gonna hard code width and height of the board right now, right? So it's gonna be something like width, and it's gonna be let's say positive. Here's an interesting thing about positive. Positive is a number from 1 up until the end of the integer, as far as I know, right? So there are naturals, the natural numbers, but these numbers include 0. We don't want our board to be equal 0, like 0 by 0 board doesn't make any sense, unless you want to be a smartass, of course, but we don't want to be smartasses, so yeah, we're not going to include 0 size, right? So it's going to be positive, so let's actually make it 5 by 5. So this is going to be like this. On top of that, since this is going to be a hard-coded value, we can mark it as constant. Right, so it's going to be constant, there you go, so we have a constant, and on top of that, the constant will be known at compile time, so the compiler will be able to do all sorts of optimization and be smartass about it. So I think it's a good when a compiler is being smartass, but when a person is being smartass, it's not usually that useful. Anyways, what the fuck am I talking about? Here's an interesting thing about Ada. You can define new types, new integer types with it. Specifically, for example, you can define a type degree, right? You can define a type degree and say that degree is a range from 0 to 360, right? And this type is like a valid integer type, believe it or not. So you can define an angle, which is in degrees, and you can just say 90 degrees, right? And it will actually work. It will actually compile, and yeah. So let's actually do something like this, and I think I can take an angle and even convert it to integer, to string, just to print it on the screen. So let me see. So it actually printed 90, right? It actually printed 90. So the range indicates that this value cannot be actually outside of that range. Belginal gifted a tier 1 sub to her Hudson Plots. Thank you so much, Belginal, for supporting the channel and her Hudson Plots. Welcome to our epic Ada Club. How about that? I know this is your favorite language. And this is exactly why I'm streaming it. Just for you, Hudson Plots. Just for you, because I like you. Cheers. Let's get the hype train rolling. Yay! Hey, hype train! Hate train. I disabled hype trains, by the way, so thank you so much for being yes, keep giving bits. The hype train actually disabled. Is it? I remember quite vividly disabling it, so if Twitch enabled it again, that's not me. I didn't enable it. The thing is, I cannot see it because I'm not using the Twitch thingy. Let's get the hate train. We do not approve of hate. All right, so we defined it as a range. But what's gonna happen if you try to put something outside of that range? For example, I'm gonna put like 40. And it generates a constraint error. Range check failed. So essentially, you can define integers that are valid within a certain range, and anything outside of that range is gonna be considered invalid. So, furthermore, there is no built-in integer types in Ada. Seriously. Because there is no need to make it built-in. In the standard library, the integer, the actual integer, is defined, I believe, like so. It's defined as a range from -2 to the power of 31 up until +2 to the power of 31 minus 1. So this is the actual definition of integer in standard library, I believe. I think this is how it's defined. And essentially, it's up to the compiler to choose an appropriate and most efficient representation for this integer. Right. So if it probably depends on an architecture, it depends on the target. So if the target is going to be x86-64, it will just use 32-bit integers to represent all of that. But yeah, on some other platforms and on some other architectures, some other definition is going to be more efficient or less efficient. It just all depends. So you see, integer is not particularly like a magical built-in type in Ada. It's just yet another range that you can define yourself, and you can define any ranges, and it will be up to the compiler to decide how to do that on the low level, on the level of a particular hardware, right? And I suppose it was done to make Ada extremely portable, because it's quite often used in embedded systems, and in embedded system, I believe there's a lot of different hardware, so the programs have to be portable like that. What about when you need to write an int to disk? What about that? So what exactly is the question? If you need to write an int to a disk, you can just write an int to a disk. So you're probably trying to ask what's the size of such integer, right? You're probably trying to ask something like that. Need to have an exact format? I don't know. So, but I'm pretty sure there are mechanisms in Ada for that, but I haven't learned them yet. When I learn them, I might as well actually tell you what exact format. Oh, and speaking of unsigned integers, unsigned integers actually don't use ranges. Unsigned integers don't use ranges. They use something called mod types. So speaking of mod, so something like degree would have been better to define not as a range type, but as a mod type. There we go. So this is another type of defining a type. It's a mod type. And essentially what it does, any operations done on this type, if they overflow or underflow, they wrap around. You see? They wrap around. And for a degree, it's actually better like that. So imagine that you have 359, and then you have an angle, right? You have an angle, and you do plus 90. And then, I'm not sure if it's going to compile, but just a second. Quality, yeah, it's not going to compile because I have to do it like that. It has to be degree, image, and let's just remove this entire thing. There we go. It's 89. You see? So angle was 359 and we did plus 90. So these are mod type. As far as I know, they work on both of the sides. So if you, for example, have a 0 degree and you subtract 90, it's going to be 270. So we see you can define the types that automatically apply modular arithmetic. And it's very useful when you work with degrees, time, and everything circular, right? Everything repeating, everything circular. And furthermore, these kind of types are used for unsigned integers. So unsigned integer, I don't remember the name of unsigned integer in Ada, but I think something like unsigned integer for 32-bit architecture would be defined as a mod of 2 to the power of 32. And what's interesting is that on x86-64, overflow, I mean, if we're talking about 64, it's probably going to be like 64, right? Overflowing an unsigned integer wraps it back to the 0. So this kind of mod behavior on some architectures is actually a valid behavior. So what's interesting is that Ada has mechanisms of describing that low-level hardware behavior, and on top of that, the same mechanism can be used for domain-specific definitions, right? Degree mod 360. You see what I mean? So here are two examples when we use absolutely the same mechanism for describing the behavior of hardware for portability and for describing domain-specific types. This is why I find Ada so fascinating. They're going a level lower. They're going a layer more fundamental, right? So usually most languages just stop at integers and that's it. Integers are hard-coded, this is your types. No, they went a little bit lower, they went a little bit more generic, and they made mechanism for you to describe these integers and stuff like that. I wonder if you can go even lower, but you see what I'm talking about? It's so interesting. Like I tried a lot of languages. I tried a lot of different languages and I never saw anything like that in any of them. This is so fascinating. But maybe I didn't try like very obscure languages, or this is so cool. It's just fucking cool, I think. A little bit higher? No, since it's more abstract. Okay, so I think in my opinion, low-high level, concrete abstract are two orthogonal things, in my opinion. Yes. Basically, by levels of abstractions, we mean like layers of. Well, it's difficult. It's just okay. It just depends on the definition. Whatever. I'm not really interested in discussing depends on the definition questions. So whatever. You get what I mean. So it has this. It doesn't matter what it's called, whether it's more abstract or more high level, low level, doesn't matter. What matters is it has mechanisms for describing these kind of concepts, and these mechanisms are more generally applicable. Whatever you want to call it, doesn't matter. These kind of discussions are a waste of time. Just forget about it. Yeah. What's interesting is that these kind of types, they also describe the ranges, right? Which means that I can use these kind of types as indices for arrays. So you see, this type defines 360 elements, right? It's a sequence of 360 elements. So that means I can define something like circle, right? And I can say that a circle is array which uses degrees. Which uses degrees as an indices of, I don't know, of integer, right? So, furthermore, you can then iterate degrees, something like for I in degree, and print each individual degree. So, degree can be used both as a type or as a range. So, and I'm iterating through all of the degrees. Put line I image. Right. And if I try to run it, there we go. I just iterated through all of the possible degrees starting from 0. Right. And since I have a circle that I defined as an array that uses degrees as an indices, you can do something like circle of I. Well, yeah, it has to be like that, and circle probably has to be properly capitalized because that's the style of Ada. And you can assign some sort of a value. Maybe you can assign like a sign of I or whatever if we had this function defined. So you see, and this array is going to have 360 elements. So types, these kind of ranges define types. They also define a range, and ranges can be used as indices for arrays. You see the ergonomics of the language. So by ergonomics of the language, I mean features of the language that fit together. So the more features you have that fit together, that actually complement each other, the more ergonomic language is. And in Ada, it's actually taken to such an interesting like extreme. So yeah, it's a very well thought out language. Holy shit, it's true. I'm so surprised. I don't like the syntax. I think syntax is a little bit too boomer for me. But the ergonomics and the semantics is just fucking amazing. Holy shit. So, okay. So how can we use this kind of stuff in our game? Right. Furthermore, you can, by the way, probably define a circle as a type. You can extract array as a type, and you can say so something like this. So you have a degree is mod 360, and then you have a circle which is an array of degrees, like of integers or something like that, right? So, and it's a very common thing in Ada to define as many of these type aliases as possible, and basically moving away from specific numbers to domain specific terms. Right, so basically what I've learned so far is that Ada developers try to build a vocabulary or like a dictionary of these domain-specific terms, and they like to reason in terms of these terms rather than like integers and whatnot, arrays, whatever. All of these things are very, like, they don't mean anything. So they usually like to create this kind of like type system. All right. So for example, how can we describe a board? Right. We can describe a board in terms of like rows and columns. So board consists of rows and columns. So for that, we can define a range of rows and columns. So rows is a range from, let's say, 0 to width -1, right? Something like this. Then we can define a separate type for columns, which is a, well, rows has to be height, by the way, right? And columns is going to be that. And then we can define a type of a board, which is array. It's a two-dimensional array that uses rows as the rows range, as the first dimension, columns as the second dimension, and it consists of cells. So we're building up the vocabulary of our domain. So we have cells, we have rows, we have columns, we have boards. And what's interesting is that this type declaration creates an absolutely new type, which is not compatible with the original one. For example, you won't be able to take a row and make any operations with integers. So you only will be able to use rows with the types of rows, and you won't be able to use columns with the type of columns, so you can never confuse rows and columns because they're separate types. That's very important. And then you can use these types as an indices for the board. Furthermore, we can take it a step even further. If we want to make a game of life that wraps around, we can declare rows and columns as a mod type over the size of the corresponding dimensions. And all of the mathematical operations that we're going to do on rows and columns will automatically have modular wrapped around them according to their size. Yeah. So this is fucking amazing. Like, yeah. So here's your like dictionary, domain specific dictionary, and it perfectly describes your domain, and you can just reason within that domain. Yeah, and this is just type definitions. We didn't get into behavior or anything like that. This is just, you know, type definitions, whatever. Is Ada good for numerical scientific applications? I'm not a scientist, I don't know, I'm sorry. I'm just a stupid Java enterprise developer. I think this is similar to how Haskell blows my mind. Well, I kind of got tired of Haskell already, so... So now we want to do what? We want to implement a function that prints a board. Let's actually first of all check if all of that compiles. Everything seems to be compiled. Let's put some sort of a side effect that indicates that, you know, the program has been run successfully. Why are you not using Emacs? Don't want to talk about that, I'm sorry. Alright. I tried it, this is not that great, to be fair. To be fair, like, I tried so much different stuff. I find Ada more interesting than Agda or Idris. Seriously. Like, I'm kind of like over of this entire like dependent type thingy. Like, it's just, whatever. Give me something like actually useful in practice. So let's implement a procedure that renders the board. So it's going to be procedure render. I'm using GNAT, which is also part of GCC as far as I know. Ada GNAT. I think. Well, basically, as far as I know, Ada Core, the company behind this stuff, develops a GNAT compiler, which has two like versions, community version and pro version. And I think community version is also part of GCC, but I might be wrong on that. Please Ada Core people correct me if I'm wrong, like, I don't know. But the thing is, you can install GNAT like via Debian repository. So right now I'm using Debian. And all of that is available in the standard Debian repository. So I just did apt install GNAT or whatever, and it just worked for me. So yeah, I don't really know the relationship between GNAT, Ada Core, GNAT Pro, and GCC project. It's kind of like a sophisticated relationship. I don't know. So, all right. So let's actually do a render board. So we're gonna accept a board. Right, and I don't think a procedure has to return anything. Yeah, it's not going to return anything. All right, so what we're going to do now, I want to iterate first rows, and then I want to iterate columns of the board. Guess how you can do that? Well, you can do for row in rows, and I'm using rows definition here. Right, so this. I'm literally using the type definition as a range to iterate through all of the rows. So I'm iterating through all of the rows. Cool. Then I want to iterate through the columns. So I do for col in cols, and now I'm iterating through all of the columns. And now I can do b row and b column. And since I know that the board is defined as an array of rows and columns, I can be sure that by doing that, I never go out of bounds, because like these boundaries are specified, right? So they're formally specified somehow, right? So I have this cell, and when I do that, I extract the cell, and cell has two values that I can now do switch case on. So I do case is when alive, I want to print this. So we're going to indicate alive cells like this. And when dead, it's going to be simply something like this, right? So then I'm going to do end case, and that's it. We implemented render board, right? We just iterate rows and columns, and then if the cell is dead, is alive, we print hash sign. If it's dead, we print dot. Also, after each row, we have to print a new line to separate everything. So we can do it like that. So here's a new line. So we also need to define a current board, right? So let me quickly do that. So right now we have 5 by 5, right? We have 5 by 5. And let me fill everything with that for now. So everything is going to be that, and we have 1, 2, 3, 4, 5. Here we go. So we have a 5 cell. So after that, I can try to render board, and see what's going to happen. So is it going to actually render anything? And of course, I keep confusing equals and assignment. It's like in Pascal, instead of equals to assign things, you have to use the Walrus separator, right? So, and let's actually try to run it one more time. Did I invalid use of sub in expression call 35? Yeah, so it has to be current, excuse me. Yes, I confused the name. There we go. It printed 5 by 5. And now I want to initialize all of that with a glider, because yeah, we want to actually test how the game of life works. So alive and alive. So glider usually looks like this. So if we define it like that. All right. Can you explain where you define the terms dead and alive? Here. There they are. So essentially cell is either dead or alive. Yes. So in the board is an array of cells with the rows amount of rows and columns amount of columns. And it's defined right here. right here. So here's defined. So all the types defined here. So now, yeah, so if we try to print that, now we can clearly see the glider. What's interesting if I change hard-coded sizes, right? If I change hard-coded sizes, I think it's not going to properly compile. Yeah. So essentially, if you change the constraints here, if you change the constraints here, you will have to change the initialization of the array. Right, but in our case, no matter what's the size of the array, right, no matter what's the size of the array, we want to fill the rest of the elements with dead. So, and there is a way to do that. So essentially, you initialize 3 first element like that, dead, alive, dead, and then you want to say, well, okay, I want the other ones to be dead. So I don't care what they are. This is how we can do that. You say others dead. So essentially, no matter what's the size of the expected array here, it will initialize these 3 like that, and the rest of them is going to be dead. And that will basically, it will be the shape of the array agnostic, if that makes any sense, right? So we'll have to do that like everywhere, right? So others dead, then here we're going to have others dead. And what's interesting is that you can do that like in a very nested fashion, right? So you don't really care about this whole row, right? And you want the rest of the rows to be like that. Well, you can do nested others definition, and that will work as well. Yes, so others, so you can actually like have nested dimensions and initialize with nested dimension or whatnot. Right, so we can also align everything perfectly, and there we go. So you can basically initialize the glider, and everything else is dead. So that's pretty cool. That's pretty cool, and I think I can also do it like this. So ignored, yeah, it keeps telling me that this thing is ignored. And there we go. So, and no matter what's going to be the size, right, now I can make it, you know, 30 by 30, 0, and there we go. It's, you know, initializes glider, and everything else is dead. Right, but we're gonna work with just, you know, 1 now. It's gonna be just 1, or 10 by 10. All right. Yeah, this is a very dang language, not gonna lie. Okay, so here is an interesting thing. So we need a function that calculates the next generation of the board. So let's define it like this. It's going to be function next, and it's going to take current as a board and return another board. It will return the next board. Others, yes. I mean, you need another layer of others if you have another dimension. Like, how often do you have like more than 2 dimensions in the arrays? Unless you're doing some linear algebra probably and some sort of like a tensors and whatnot. But generally, if you're doing some sort of like a pleb enterprise development, you probably don't need more than 2 dimensions. I don't know. All right. So, yeah. So let's define a function that takes the current board and returns a new board. Right. So what we're gonna have here is we're gonna basically iterate through all of the cells, check their neighbors, and then make decision whether the next generation is gonna be dead or alive. Right, so we're gonna define a result, which is gonna be this array, board array, not initialized, because we're gonna have a loop that initializes all of that, and we're gonna just return the result. Right. So let's start iterating. We iterate in row in rows. We iterate in all the rows and loop. Then we iterate in all the columns and loop. And now we need to count the neighbors. So we need a function that counts the neighbors. So let's define such function. So we're going to do a little bit of a top-down development, right? So count neighbors. Neighbors, is this how we spell neighbors? I think you spelled it slightly different. So I think it's GH, neighbors. Okay, so and what you want to have here is basically the board right? So the board for which you're counting, then a current row, and by the way, you can use the type rows here. So you use rows to iterate through all of the possible rows, and then you use it here to indicate that you cannot confuse rows and columns, by the way. These two things are a completely different type. You can never confuse them. If you try to use columns for rows and rows for columns, it will be a compilation errors, and we're going to see that pretty soon. So it returns an integer, is begin, so it's going to be end, and for example, I'm going to return 69 for now. And let me try to compile all of that just to see if it compiles. It does compile, and now look. So if I try to, for example, so it's going to be n integer, initially it's going to be 0, and then I want to do n equal count neighbors, right? And I use row and column, right? I use row and column and try to compile that. Yeah, it has to be current. If I try to compile that, that will compile. Yeah, there we go. As you can see, it compiles. But now, what if I accidentally confuse rows and columns? What's gonna happen? It doesn't compile. Expected type row, find type column. Can your Rust do? Well, I mean, Rust can do that, but you have to explicitly like define that. But think about Ada is that Ada kind of encourages this kind of style of development. You can do this kind of style of development in any language where you can define new types, sure, but none of the languages actually push you towards this kind of style. Right, so and this is what's interesting about Ada. It like really encourages you to write like that and define as many of these type aliases as possible. They're not really type aliases, they're completely different types. Right, so that's what makes it interesting, right? It's not like it's a possible way of developing in Ada, it's the encouraged way of developing in Ada. Anyway, so here's the thing. So this thing is not implemented yet, so we're going to implement count neighbors a little bit later. So we're doing top-down development. Yeah, fish is spelled, yeah. Classic. That verbosity though, well, it's an old language, what can I say? And it's also more of a like enterprise language, you know, enterprise people like it. So here's the thing. In C, you would probably define n, define n somewhere here, right? You don't want this n to be visible where it's not really needed. So in C, I would really somehow define n here. But Ada is like Pascal, right? It has a very specific place where you're allowed to declare variables. In C, you can declare variables pretty much anywhere, right? But in Ada, where there are specific declaration sections. But what's interesting is that you can create a declaration section pretty much anywhere, especially in the places where statements are required. So to do that, you have to use a special declare syntax, right? Declare, and that creates a section where you can just declare a variable. And then you do begin and end. And this is going to be the body where n is visible. Outside of this body, n is never visible to anyone, and you can get rid of this declaration now. So, because the amount of neighbors only needed for that specific cell, because different cell is going to have a different amount of neighbors, so we can basically narrow down the visibility of this amount of neighbors. Okay, so, and essentially the decision depends of our further decision depends on whether the current cell is dead or alive. So we're going to do this thing again where we're going to take current and check its cell, right? So it's not off, excuse me, it's just Haskell, you know, in my brain. So when dead, we're going to have one situation. When alive, we're going to have another situation. I'm going to end the case. There we go. So, when the cell is dead, it becomes alive when it has exactly 3 neighbors according to the rules of the game of life. So that means result result, row and column is going to be equal alive only if amount of neighbors equal exactly 3. Otherwise, it's going to be dead. There we go. So that's how we do that. Next thing. When the cell is already alive, it stays alive if the amount of neighbors is 2 or 3, and becomes dead if it's less than 2 or greater than 3. So this is how we're going to express that. So result, row, column, if n, and we can easily check something like if n in from 2 to 3, so we can check ranges. Instead of checking if n is equal to 2 or 3, we can just check is n within that range, but it also includes the edges. Then it stays alive, otherwise it becomes dead. So yes, this is how it goes, and I think I also maybe want to split things by lines, so it's a little bit easier. There we go. So this is the implementation of the next generation, right? It takes the board and returns you the next generation, right? And everything is type safe. We're using the domain specific terms, so we don't use like integers directly except here. But this is very interesting, right? So we use a very like generic term here instead of our domain specific term, but we don't have to. We know for sure that the amount of neighbors is never going to be greater than 8, right? According to our domain, according to domain that we're working in, it's never going to be greater than 8. So maybe we could push it even further, even though it feels a little bit unreasonable, but we can push it even further and say that we have a type neighbors, which is a integer from a range from 0 to 8, right? And when you count neighbors, you can return neighbors instead of integer. And what's interesting is that now returning 69 will fail, because you can never have 69 neighbors in Game of Life. You can only have from 0 to 8. So we add additional check for this kind of stuff, you see? So yeah. So I suppose from what I learned from different Ada tutorials is that you have to introduce a lot of domain-specific types, and this is sort of like a good style of development in Ada, and it's also a very interesting style of development in Ada. All right, so can we compile all of that? It doesn't compile because yeah, so 36. And yeah, so it instantly caught an error, right? So count neighbor returns neighbors now, but I'm trying to assign it to an integer, and now I have to say that it's a neighbors, it's not it's not integer, and now it compiles. All right, so yeah, because every time you introduce a type, it's a completely different type which is not compatible with other similar types. All right, looks cool. Now let's try to implement count neighbors. So to count neighbors, how do I usually count neighbors? How do I usually count neighbors? So I use this trick all the time because it enables me with getting rid of a lot of hard coding and stuff like that. So let me see. So you have, we don't have OMG Ada actually. It's kind of sad. I'm not gonna lie. Maybe somebody have to come up with the OMG Ada. So we're gonna have this kind of thing. So I'm just making a grid. Right. So you have this cell and you want to iterate through all of the neighbors of that cell. But what's interesting is that all of the neighbors and yourself are located in 3x3 square. So instead of like building up some sort of tables or pre-computing the neighbors, what you can do, you can just iterate 3x3 cell, right? So you can do 4 dr in -1 1, and then a nested loop is going to be 4 dl in it's not really DL, DC, right? Delta colon -1, 1, and basically add this as a deltas to your current position, and basically ignore when dr and dc are equal to 0. And this way you basically just iterate through all of the numbers. So it's a pretty convenient way of actually going through all of the numbers. And we're going to use that approach as well. All right, so let's quickly do that. So so for let's call it delta row, right? It's going to be in range. I think you don't have to specify the range. You can do something like -1, 1, right? Loop and loop, right? For delta column in -1, 1, loop and loop. And what we're going to do here, we'll need to declare begin end, and we're going to have actual row, but a row is already taken. You see, this is the starting position. Since it's a starting position, since it's a center of that 3x3 region, we're going to call it row 0 and column 0, right? Something like this. And in our case, row is going to be rows. The type of it is going to be rows, and it's going to be row 0 plus delta row, right? And since rows is a mod type, we can expect it to actually automatically wrap around, right? And let's do the same thing with the columns, right? So it's going to be something like this, and there you go. This is how we iterate through all of that. Let's check if it compiles, and it will not compile because at line 33, we have an invalid operator types for operator plus. So left operand has type row, and the right operand has the type standard integer. So row 0 is rows, but delta row is integer. So even though this very strict static typing is very useful for catching errors, sometimes it could be annoying like that. Right. Furthermore, if you want to define a range of a specific type, you can try to do something like this. I think you have to do something like rows range, and essentially it defines a smaller range within this range. Right. It defines a smaller range within this range, so these types are going to be the correct types. So let's actually try to do that. It's going to be this, and it does compile. Which is quite surprising, but okay, I'm gonna take that. You know why it is surprising? Because -1 is not part of the rows and columns range. That's why. Right, because the range of rows and columns is from 0 to height -1 and 0 to width -1. So -1 is not part of that range. Yeah, -1 gets wrapped around, which probably means that this value is bigger than this one. Okay, so let's actually try to conduct an experiment. Let's try to conduct an experiment. I'm not gonna render this road, and I'm gonna just do for row in rows, loop and loop, and I'm gonna do just put line row image, right? So let's see what kind of values we're gonna get. So we get from 0 to -9. If you try to do something like from -1 to 1, you're gonna get 3 values from -1, 0, and 1. And now, if you try to do rows range, you're gonna get value. You're not gonna get anything, because instead of range from -1, you get a range. Rows is a height, yeah, height -1 to 1, which means that the beginning is greater than the end. So, okay. I wonder if GNAT even warns about this kind of stuff, right? Because even though this feature is supposed to catch bugs, if you use it like that, it actually introduces the bugs that you have to be aware of, right? So is this really language actually useful for catching bugs? So let's take a look at the warnings. Formal parameter b is not referenced, variable row is not referenced. Yeah, welcome to a safe language. How safe is that? right? So you basically introduce the bug by this thing. You didn't notice that you're trying to reference this thing outside of the range, and the compiler didn't even warn you. Nice language, Ada Core. I'm joking, it's a cool language. Breaking add stream, yeah. So essentially, to fix this bug, right, this bug, which Ada compiler didn't warn us about, right? In the warnings, I didn't see anything, and I enabled everything from GNAT warnings. And to be fair, I'm using a very old GNAT compiler, right? Probably like the Ada software is very old. Russian hacker bringing it with formulas. Yeah. So the lesson here is that there's no silver bullet. Okay, right? So. Ada is a safe language, but I mean, even Ada's safety has its own limits, right? So what we want to do here is, and I'm pretty sure I'm just using it incorrectly, right? So some Ada developers probably will come to the comment section and tell me how wrong I am, and you have to use this obscure feature from 1969 or whatever. But anyway, so the way to fix that problem is to actually shift the square. So the values are included in the ranges. So essentially, we can say that instead of iterating it like that, we can iterate this square instead, right? Instead of iterating this square, let's iterate this one, because then the deltas will start from 0 up until 2, right? So, and that is a little bit better. Right, it's going to be from 0 to 2, and then from 0 to 2. So these are located in the ranges. And now, what we're going to do, we're going to just subtract 1 from the final row, right? We're iterating a slightly offset square, and when we're calculating the final row and column, we actually bring it back. And since instead of using negative numbers, we use subtract operation, all the modular stuff is actually applied, right? So -1 is not part of the modular range, but you can still subtract, and subtraction will do the modular stuff, right? So basically we got rid of the negative numbers and introduced subtraction. And Ada compiler was not helpful in this situation, by the way. So, okay, so we have rows and columns. And the next thing we need to do, we need to check, right? So if B row and column is alive, we want to increment some sort of a counter, right? So let's actually have some sort of a counter. So we're going to have a result, result plus 1, and result is this integer. Initially it's going to be 0, right? So then we're going to have end if, and then we're going to return the result, right? If we try to compile that, it does not compile because expected type neighbors, but we have a type integer. Yeah. We introduced this new type neighbors. Okay, so this is the neighbors, and now this thing will compile. Okay, so what's interesting is that you can forget to return result. Right, you can forget to return result, and I think Ada will complain about that, right? So the thing is, like, recently I learned that Ada has a very interesting construction called extended return. Extended return, essentially return that has a block. So essentially it defines a block which evaluates something and then returns that value. So it's kind of an interesting thing. Yeah, so the return statement looks like this. You return an identifier, and then you define a block, and you compute that identifier within that block, and that thing returns automatically. So instead of writing it like that, you can say, you can remove that, and you can remove that. So you don't need that. Then you do something like return result neighbors. You also initialize it with 0, and then do, and you wrap all of that in that return block. So apparently Vim doesn't know about this new block. It's a relatively new feature, I heard. Yeah, this is how it works. Right, so essentially block of code as return. You define the variable. Within that block, you compute that variable, and that variable automatically gets returns out of this block. So you cannot add an integer to row type when you had just integer range for deltas, but you are allowed to subtract a literal. Yeah, so I think literal, I feel like, I don't know for sure, but it feels like literals automatically get the type of the variables in the expressions of which they are participating, or something like that. See, so the type of this one is rows and the type of this one is row, and because of that this literal also has a type of row. So I think literals basically adapt or something like that, but variables do not. Variables do not adapt. So actually, yeah. I was developing some time ago a programming language that compiles to WebAssembly. I put the development on pause, but I actually encountered a very interesting problem that is similar to that one. Essentially, I had to postpone the type inference for literals until I know the types of the surrounding variables or something like that, because otherwise the type system was too strict and not very useful. So essentially I had to implement a mechanism that adapts the types of literals to the types of variables with which they're interacting and whatnot, if it makes any sense. Right, I think it's kind of similar what's going on in Ada as well. But at least that's what I feel like. I'm not a language developer, so I know nothing about language development. All right, so everything seems to be compiling. And what's interesting is that we can use the return construction here as well. So we can just return all of that, remove all of that, I mean, and then say return result. So we use result here, which is a board. We're not going to initialize it because the loop initializes it, and we're going to do and return. Yeah, Vim is not really helpful. I think Vim just doesn't know about this construction. Cool. So will that compile? I think it will compile. Cool. So, and everything compiles, and as you know, chat, say the line. If it compiles, it works. Anyway. So much shit happened in production after this phrase. Am I right? Am I right? Anyways. So, what we need to do now, we need to call next in loop and keep rendering. So in Ada in Ada you have a special construction for infinite loop, right? It's like in Rust, right? So in Rust you have loop construction, and in Ada you have loop, and this is an infinite loop. This is how we define an infinite loop. And if you try to run this entire thing, it will just print the shit indefinitely, which is not particularly useful. Also, there is no separation between the rendered frames, so we probably want to add a new line here, and now we can see a little bit of a separation between different frames. So, but we don't call next. Let's call it next. Current equal next current. Oh, and by the way, here's an interesting thing. If you have two arrays of the same type, the same size, you can assign one to another and it will copy them. Yes. Arrays that are known at compile time act like values. Can your C do that? I'm sorry. Yeah. So the sizes of this array, they're known at compile time, like everything known, so you can literally treat this like a bunch of memory as a value, and it will be copied around, it can be allocated on a stack, it can be done all sorts of shit in here, so it's literally just a value, right? The size unknown, it's a value. So you can have next, and it just reassigns it. What's the difference between function and procedure? It's the same difference as in Pascal. Function returns the value. Procedure doesn't return a value. Functions is for functions in a sense of, you know, math, and procedures for side effects. Yes, with malloc and memcopy. Yeah, sure. Cool. Sure. Sure, C developers, sure. Okay, so now if I try to run this entire thing, it doesn't work. We fucked it up. Cool. Alright, so it kind of stuck here. I don't know why, I don't know how. But let's try to troubleshoot that. So let's actually do for I in from 1 to 2. So let's actually limit all of that to 2 iterations. It's actually kind of cool how you can quite easily, syntactically, transform an infinite loop to a for loop, just adding this thing. And then you can just remove it. I wonder if I can do something like this. Can I? Yeah. So I'm going to put it like that. It performs 2 iterations, and then I can just comment it out, and it becomes an infinite loop. Okay. There is something... I said that I don't really like the syntax of Ada, but this syntactic feature is cool. Look at that. So this is syntactical difference between for loop and infinite loop. Literally one comment away. Very handy. Okay, maybe there is something interesting in the syntax of Ada. All right. So, okay, I'm taking my words back because that's cool. So Ada is especially cool for debugging and stuff like that. Alrighty. So with 2 iterations, it completely failed, and let's actually see. Maybe I actually like did some sort of like a logic thingy. Logical thingy. From 0, 1, 2, right? 0, 1, 2. It's range. No. So in neighbors everything is okay, right? I'm iterating data row from 0 to 2, 0, 1, 2, and column 0, 1, 2. Then I add this thing and I subtract 1, so everything's okay here. If it's alive, I increment the result. Result is initially 0. Okay, don't see any problems here. So then, this is a rows, this is a columns. We compute the amount of neighbors in the current. Then we take a look at the current cell. If it's dead, right, and has exactly 3. Okay, I see the mistake. We don't exclude ourselves. You remember how I said that to iterate neighbors, you also have to exclude yourself? I forgot to exclude myself. Yeah, I forgot to exclude myself. And by the way, Ada was not helpful to find this bug. Why? Ada core. Why Ada was not helpful to find this bug? I'm joking, it's a joke. Alright, so... Also, why not do range -1 to 1? Congratulations! Welcome to the stream! You missed like a half of a stream where we had a discussion about all that. Welcome, Pengo Ray. It's like... Welcome to the stream, right. Yes, we cannot do -1, 1, and you missed why. I'm really sorry about that. Alright. So, let me see. something Ada bad, something, yes. Alright, if... how we can do that? If delta row not equal 1 or delta column not equal 1. I don't remember, I think OR is not short-circuited. Yeah, I think it's not short-circuited, so this value is not going to be like optimized in some sense. But we don't do any side effects, so I don't think it matters in that particular regard. So, Yisu, Kawai, this 1, 2, 3, 4. Alright, so let's actually do that. And I think this is a correct next state of the glider. So now, if I limit that, not limit, but turn the infinite loop yet again, yeah, as far as you can see, this is a moving glider. This is a moving glider. But this rendering way is kind of pepega, right? Because you cannot see shit in that mist, right? So you cannot see shit. It would be better to, you know, redraw it constantly. And for that, we can use escape characters. So essentially, after we drew the board, what we need to do, we need to move the cursor back to the top left corner and draw it again. So it doesn't actually fill up the screen with nonsense and whatnot, right? So let's quickly try to do that. So because of that, we don't need a new line, and we need to use the escape symbols. So the ASCII code of escape is what? Not ANSI, ASCII. SASC. I think it's 27. Yes, 033. It's a octadecimal representation. Yeah, octadecimal representation. This one is 27. So it would be better. It would be actually easier to use decimal. I don't remember if Ada supports octadecimal literals. Ada octadecimal literals. Let me see. Yeah, man ASCII is actually super useful. Seriously, I use it all the time. I learned it from Dennis Clark, Lost Miles. Octal. So they call octal. Can I click on that? Oh no fucking way. Really? Seriously, this is how we do that? So if I want to like 8, is that how we do that? Octal or just base 8? Okay. Oh, that's so fucking useful. Holy shit. Or maybe I can even do it like that, so it has to... Holy fucking shit. You explicitly say the radix or base. I just googled Ada SDL2 bindings that exist. Well, it's not surprising because Ada has interop with C, and SDL2 SDL2 is written in C, so it should pretty much, you know, be trivial problem to implement the bindings. Okay, so here it is, and now we have to use character val, and that will turn this code into a character. So then we can print that character. Right, so we're printing that character. Then, as far as I know, you have to add this thing, if I remember correctly, right? So ANSI escape sequence. Let me see. ANSI escape code. Control sequence mode useful sequence in next section. Well, I can basically steal them from my example in 8, so because I'm gonna just waste a lot of times. Okay, come on. Yeah, I'm gonna just... I already did that, so I don't need to do that one more time. So yeah, it's opening then you have height or width. It's actually the other way around, right? Yeah, it's the other way around. So then I'm gonna do height, image, then A. Right, so this is the rows. Then we have to do the columns one. So it's gonna be width and D. Then if we try to run that, it did not work, surprisingly enough. It did not work. That's very interesting. Why it didn't work? Is that because of a new line? I don't think I need to do a new line though. Maybe I fucked up this thing. So let me try to do 27. Nah, doesn't work. So was it something else? 1H. Yeah, that's actually useful. So the problem with Ada actually is that it also does not properly render integers. It always tries to add like some sort of a space there, which is extremely annoying, but that's what Ada does all the time. So you have to first troubleshoot this kind of thing like this. Yeah, so it adds this space, which probably screws up like everything. But sometimes it works actually. Sometimes it works, but I don't know if it will work this time. So if you add the escape character, right? Is it 27, right? Wait, ASCII. Yes, it is 27, because I'm not sure if it's 27. Let me see. Well, it did the thing. It did the thing. And I don't see any problems with that. Maybe I need to make it new line. So yeah, I'm not sure. Let's try to do a new line. So new line didn't help. So okay, so let's try to do slightly differently then. What if I make it 10 A D and just remove everything here, just to troubleshoot, just to make sure that everything's okay here. Yeah, okay, so the problem here is that it adds that space there. That's the actual problem. So you need to try to make sure that it doesn't add that space there. And I remember that it wasn't really easy task. It wasn't really easy task. So maybe you, yeah, also it rendered it really strangely. Right, it renders it like that, which doesn't really make much sense. So maybe you have to do something like a 9, right? Actually, maybe like 11. Yeah, it has to be like 11. But if you add the space, right, that Ada always wants to add when you render an integer. By the way, I don't understand why Ada added that space, and I tried to Google it up, and I think there's no way to not make it. It's not working. Oh boy! All right. So let me see just a second. I remember that I actually managed to do that somehow. No, apparently not. Alright, so I suppose we'll have to live with this half-assed solution, which still doesn't work. But it works for 2 of them. Wait. Oh yeah, because I added the space, I'm sorry. This is really disappointing, but okay, I mean, yeah, sure. But... yeah. Can you choose Subster? Probably. I can probably do Subster. Why not? It's really strange. Sometimes it works, sometimes it doesn't. I actually did this example today, and doing what I'm doing right now actually worked, but now it doesn't. It's so annoying. It's so annoying. Like, it worked, and now it doesn't work. And like, if Ada just let me properly do this thing, like without all of this formatting and whatnot, it would be super nice. But it's kind of strange language. Like, it's really nice language, but there's like this random poops everywhere. You know what I mean? Like, it's really interesting, but randomly you just step into something very nasty. Like, and it's like, why is this a thing in a language? One more time. Like, it's just really strange. And you have to deal with that. But anyway. Anyway. So... it doesn't work. Assuming negatives don't have space. Wait a second. Is this because of the team ukes? It could be because of the team ukes. Oh my god. Did I waste my time because of the team ukes? I cannot believe that shit. Wait a second. Where was that? Ada goal. And if I try to... Yes! I think it has something to do with TeamUX. Yes! I see. TeamUX doesn't handle it properly. Oh my god. Okay. Ada good. Okay, Ada good. Not it's not Ada bad, it's TeamUX bad. Alright. We'll keep that in mind. We'll keep that in mind. Ada good. Sure. Whatever. But it's too fast. So basically we can use a delay, right, and slow it down. Duration like 25 around. And we'll need to recompile this entire stuff. Gnat make gnat wa, and it's gonna be goal adb, and then we're gonna just run it. And I forgot to add a semicolon, and it did not properly recompile, and there we go. Isn't that amazing, chat? Isn't that amazing? So it's gonna wrap around and it's implemented in Ada using all of this, you know, domain-specific goodness, right? So we have this domain-specific dictionary, we have cells, rows, columns, boards, neighbors, and here you go. So spicy goal, yeah. Did you guys like this small demonstration? Do you guys like this small demonstration? I think it was pretty cool. So, and of course you can modify, for example, width. It's gonna be 20 now, right? It's gonna be 20. Yep, and it doesn't work on 20. Yep. Okay. Escape codes, man. They're hard. They're hard. Okay, so I'm gonna just upload all of this stuff to clean. That code actually looks very clean. Really? You think so? So, well, I mean, it's a pretty good code, a cool code. Not gonna lie. So, and like the fact that it uses like domain-specific terms everywhere is actually pretty cool. Switch width and height. Ah, yeah, that's a good point actually. I didn't think about that. So it's gonna be height, and this one is gonna be width, and yep. So now we're talking about. That was really weird. Okay, so we're gonna say width 20, and it's gonna be like this. There we go. So pretty cool. A is up, D is left, I think. Okay, I see. Sure. Everything works. And we didn't even have to do any modular arithmetics ourselves because the rows and columns are modular types, and any operations on them are automatically wrapped around. Ada makes you overconfident with no mixing up columns and rows. Yes, exactly. But I mean, this part of Ada is not properly type checked, so there's nothing much I can do about it unless I introduce like special functions that accepts the corresponding types and whatnot. Alright, so let's actually upload the shit on GitHub. How about that? How about that? Isn't that amazing? I think it's goddamn fucking amazing, man. Alright. I really want a cup of tea, but my kettle has died. So... let me continue. Dead kettle, yes. What's up, Odd9? Hello. Press F for a dead kettle. Alright, so Ada, game of life in Ada. MongoDBOS. Alright. So Ada programming language. Ada programming language. So let's do all of the documentation. Hello. So this is official website. Let me see. Okay. Quick start. What is escape code? 27? What do you mean? It's a special code. It's like escape goat, but it's escape code. So we can read about them like ANSI escape sequences. So if you don't know what it's all about at all, just read this Wikipedia article. You're welcome. All right, read it all, because that's going to be on the exam. Okay, so we have to do gnat make, gnat wo, and we're going to do goal adb, right? And then you just do goal. All right. Install gnat first, right? So, and let's see where you can install it, right? Gnat download. Exam when? Tomorrow. Tomorrow is the exam. Did you prepare for the exam? RISC-V, yes, and you have to use a RISC-V compiler for Ada. I didn't. God damn. Well, good luck then. Wait a fucking second. Is it a cross compiler or is it a... Can I use it on my machine and cross compile to RISC-V and then test something? Can I run my game of life in RISC-V? Why do I keep hitting myself? So, well, that would be actually kind of interesting to explore. Let me try to Google it, to download that. Okay, it's downloading 187 megabytes. Okay, while it's downloading, I'm gonna just, you know, continue doing this thing. Yeah, so it has to be like this. Install that first, then do that. Okay, cool. Next thing I need to do, license. All of that is going to be released under MIT. So also, oh shit, I need to git ignore some of this shit, right? Git ignore goal ALI and O. Right, do I need anything else? I didn't think so. No, I didn't think so. All right, git init. Ready, set, go. And let's push that stuff right into the repo. Ada goal. So maybe I should also describe what exactly. Thanks for escape codes. I didn't invent them. Right. You can thank ANSI. I think ANSI is the name of the. Yeah. Thank American National Standard Institute. Not me. I didn't invent them. It's them who invented them. All right. So. All right. Thanks, Obama. Yeah, sure. Okay. Simple game of life implementation in Ada. All right. So, and I'm gonna put it here. We're gonna release it in public, and just, you know, create the thing, and there we go. So, oh shit. Okay, it's gonna be add description of the project. Add description of the project. Then add origin. Oh shit. Oh shit. Where is the URL? Bruh. Here it is. Here's the URL. Cool. Oh shit. I'm sorry. Sorry for what? And I'm gonna push that right into the repo. Chat, get ready. Chat, get fucking ready. Are you ready? Here it is. Go grab it. It's available for everyone. Game of life in Ada. Isn't that amazing? Isn't that amazing? So, let's do the thing where I'm gonna take a screenshot. What we're gonna be... Is it possible for me to record like a video of the screenshot? I wasn't ready, see. I'm thinking how we're gonna do it. Like a screenshot, like taking this as a screenshot is kind of lame. But maybe if we make it smaller, ADB, Ada virus. What? What? Okay, let me try to recompile this entire stuff. So here it is, a very cute glider. Okay, so this is gonna be okay, so if I do it like that, right? Yes, that makes a perfect screenshot. I was just setting up the screenshot, right? So yes, that's a perfect screenshot. All right, so it's gonna be not max but Emacs. So, and I'm gonna put this thing here. Where is my screenshot? There it is. I'm gonna copy paste it. Thumbnail. And we're gonna have this thing here. Thumbnail. Doesn't your window manager swallow? Well, it only sucks. So it doesn't swallow. I don't know what you're talking about. You probably trying to make a joke out of the context that I'm currently in. I'm sorry. All right. So let me see. Oh, there's this shit. Okay. All right. So maybe I'm gonna do it like that. Add thumbnail. And thumbnail, reduce the size of the board. And push that right into the repo. All right, so I think everything is prepared. I think everything is actually prepared. Cool. Give it a star and everything. You know, the usual. And yeah, maybe this stream was actually useful for somebody, who knows. But yeah, that's enough of Ada, and I see you all tomorrow.